Hey there. If you've ever streamed a movie, checked your email, or even worked on a document with someone online, you have used the cloud. It's one of those amazing technologies that has totally transformed our lives, and most of the time it's just working silently in the background. So for this explainer, we're going to pull back the curtain and really see how this invisible powerhouse actually works. I mean, really think about that for a second. How is that even possible, right? That incredible power, that instant access to pretty much anything you want to watch, it all comes down to the cloud. So to really get a grip on its power, we first have to take a step back and look at what life was like before the cloud. So before the cloud came along, pretty much every company, every organization had to own and run its own computers. This was the age of the server room. That physical, often chilly room down the hall filled with humming, expensive, and really power-hungry machines. And this really highlights a huge shift in how we think about technology. The old way was all about ownership. Your data lived on a physical server you owned, and it was basically chained to that one location. The cloud model, though, is all about access. Services are delivered from these massive remote data centers, which frees up your data so it can be reached from anywhere, at any time. And believe me, this old way had some serious drawbacks. Just buying and maintaining servers was incredibly expensive, and if your website suddenly got popular overnight, well, you couldn't just magically add more power. You had to physically buy and install more machines. And forget about working from home. Your data was stuck at the office. It was a model just full of hurdles that was practically begging for a better solution. But the cloud didn't just appear out of thin air. It wasn't like a light bulb just went off one day. Nope. It was the result of this really fascinating evolution in how we think about computing power. It was a journey of solving one problem at a time, with each new step building on the last. This journey started with these isolated servers, right? Each one was basically its own little silo of power. The first big leap was to pool them all together, and then the final, crucial step was to distribute that power across huge decentralized networks. Let's take a look at the two big ideas that really made this all possible. So, first up was cluster computing, and the idea here was honestly brilliant. What if we link a bunch of similar computers together so they act as one big supercomputer? A central cluster head would be the boss, managing the workload and handing out tasks to all the other machines. This gave us a lot more power and, importantly, more reliability. If one machine failed, another one could just pick up the slack. But you see where this is going, right? This created a new critical flaw. The entire system now depended on that one single cluster head. If the head failed, the whole cluster went down with it. It was a single point of failure, and in the world of computing, that's a huge risk. So the question became, how do you solve for that? And the answer was grid computing, and the solution was pretty radical. Just get rid of the head altogether. Grid computing connected all sorts of different computers across different locations, and they all operated as peers. It was completely decentralized, which allowed all these systems to share resources without some central bottleneck. This was a massive, massive step towards the kind of flexibility we see in the modern cloud. Okay, so with all these pieces falling into place, you've got pooled resources, you've got distributed power, and you have internet connectivity. The stage was set for the main event. Let's put it all together. So what is cloud computing really? Well, it's the on-demand delivery of all those computing services, servers, storage, you name it, over the internet. It takes that distributed power we got from grid computing and packages it in a way that pretty much anyone can access from anywhere. But there was still one more piece needed to make it a true revolution. And that final piece, this was the real game changer. It was a revolutionary economic idea called utility computing. The question was, what if you could treat computing power just like electricity or water? You just plug in, use whatever you need, and you only pay for what you actually consume. This pay-as-you-go model made high-performance computing affordable for everyone, not just giant corporations. All right, now that we know what the cloud is, let's look at how we actually interact with it. It turns out there are three main ways, or service models, and they basically determine how much control you have versus how much the cloud provider manages for you. So you can think of these service models like a pyramid. At the bottom, you have the most control. You're building everything yourself. And as you move up the pyramid, the provider starts to handle more and more of the work for you. To make this really, really clear, let's just think of it like getting dinner. So at the very top of our pyramid, we have software as a service, or SaaS. This is just like going out to a restaurant. You don't worry about the kitchen, the ingredients, or the cooking. The restaurant handles all of that. You just show up and enjoy the meal. This is your Google Docs or your Netflix. You're just using the final finished product.
Okay, so in the middle is Platform as a Service, or PaaS. Think of this like getting one of those meal kits delivered to your house. You get all the ingredients, you get the recipe, but you use your own kitchen to do the actual cooking. For developers, this means the provider gives them the platform and the tools, but they're the ones building and running their own applications on top of it.
And finally, at the bottom, at the foundation, we have Infrastructure as a Service, or IaaS. This is like renting a fully equipped commercial kitchen. You get the ovens, the stoves, all the space, but you have to bring all your own ingredients and your own recipes. This gives you the most control. You're basically renting the fundamental building blocks, servers, storage, networking, and you build whatever you want from scratch. So here's the trade-off in a nutshell. With IaaS, you are in the driver's seat. You're managing pretty much everything from the operating system up. With PaaS, you get to focus just on your app and your data. And with SaaS, you just hand over the keys and let the provider do all the driving. It's all about picking the level of control that you actually need. Okay, so we've covered how you use the cloud. Now let's talk for a second about where your cloud infrastructure actually lives. This is what's known as the deployment model. The two main types you'll hear about are public and private. A public cloud, think AWS or Google Cloud, is kind of like living in a big apartment building. It's really economical, and you share the underlying infrastructure with a bunch of other tenants. A private cloud, on the other hand, is like owning your own house. It's built for just one organization, so it offers way more control and security. But, as you can imagine, it comes at a higher cost. But in reality, it's often more complicated than that. A hybrid cloud can give you the best of both worlds, letting you keep sensitive data in your private house while using the public apartment building for less critical stuff. And then there's something called a community cloud, which is like a gated community, where organizations with common goals, like, say, government agencies, share infrastructure to meet their specific needs. So we've gone from these clunky local servers all the way to this incredibly flexible, powerful global system. But what does this all actually mean in practice? Why has the cloud completely changed the game for technology? Well, it really comes down to a few key superpowers. The cloud basically gives businesses superpowers. With scalability, you can handle a sudden spike in website traffic without anything crashing. You slash costs because you're not buying tons of expensive hardware anymore. You can launch new ideas in minutes, not months. And because your data is stored across the globe, you're protected from disasters, and you can access your work from literally anywhere. It's just a fundamental shift in speed, power, and efficiency. So, from the limits of a single server stuck in a room to a global on-demand utility, the story of computing has always been about overcoming boundaries. It really makes you wonder, doesn't it? What are the boundaries we're facing today? And what will that next big leap in computing even look like? That's definitely something to think about.